We are the Composite Bike Frame Group, and we would like to tell you about our mechanical engineering undergrad senior design project. But first, let's meet the team.
Hello everyone, I'm Mohamed Lamer.
I'm Muhammad Rafai.
My name is Jordan Sayre.
And I'm Ethan Fraser. Our sponsor is Mr. Jerry Visser.
Composites engineering is becoming increasingly popular in recent years, from wind turbine to high-end sporting goods like golf clubs, tennis rackets, and most notably, bike frames.
But that high-end composite frame tends to come with a price. Popular bike manufacturers begin their pricing for carbon fiber bikes at $2,000.
In addition to the steep cost to the consumer, the standard method for creating a composite frame uses a steel or aluminum mold for infusion.
And each of these molds are model and size specific, meaning if a given model needed to be available in 6 sizes, then the manufacturer would need 6 different molds.
The purpose of our project is to innovate a much less expensive means of manufacturing and infusing a composite bike frame. The objective for the frame and our overall bike assembly is to meet the same physical requirements as a regular bike while reducing weight and manufacturing costs.
To avoid investing in an expensive bike frame mold, our team came up with a novel means of infusion. The geometry of the bike is laid out on an aluminum plate, where it is then infused flat against the aluminum, creating one side of the frame.
We then repeat the process with the geometry of the bike laid out in the opposite direction.
PETG 3D printed fasteners are made to clamp the 2 plates together while spacing them wide enough apart for the bottom bracket, seat tube, steering column, and wheels. Holes are bored into each of the plates to allow for the insertion of the fasteners using bolts, washers, spacers, and nylock locking nuts. Our final frame was designed in an oval shape to exhibit the advantages of our method of manufacturing, since using our method could potentially create any kind of bicycle geometry from a single mold. Our oval-shaped bike frame went through many iterations, simulating and analyzing the frame every step of the way to ensure that physical requirements continued to be met.
Before spring break, we had already performed several test samples. Our 2 most recent samples performed better than calculated values for tensile and bending strength. This reassured us that our final composite will be as strong as we assumed in our simulation and analysis.
We wanted to continue this project even after the campus shut down, so we performed an infusion in our sponsor's garage, building a plywood surface rather than aluminum upon which to infuse our frame and continuing from there. While this was just a practice run, our team is confident that without the campus closure, we would have had 2 successful infusions and completed our frame.